We'll be paying attention to mutually exclusive events. Section A, Mubenya Bibisa. I'm the member of her, and I can say intersection B, and then she knows her 0. X and Y are two independent events such that the probability of X is 3/7 and the probability of Y is 14/15. Find the probability of X intersection Y. Hello.
Hi.
So you know when it's about intersection, it's about what? Multiplication. So you just go to the multiplication formula. That will be probability of X times probability of what? Y. So what's the answer, please? Probability of X is what?
3/7.
Times the probability of Y is what? I guess it's what is that? 42/. I think something can cancel out. 3 will cancel itself one time, go into 15, 5. 7 will get into itself 1, go into 14, 2. So you have 2/5. It's better that way. Okay, so that is it. Now, sometimes you'll be given X intersection Y, pay attention. And then you'll be asked to investigate for one of these. So just once you know the rule around intersection, go to the formula, put the numbers you have right under them, and then you'll be able to search for the other. Take a look at question number 2. Try it and let's see. Question number 2. You recording?
Yes.
Pause that. Question number 2. Probability of A intersection B. Why is it that you start and you are unable to end? What's the formula? That would be probability of A times probability of B. What's the probability of A intersection B? Check from the question. 1/8. I believe you did this.
Yes.
Because what's probability of A? 5/12.
Yeah.
Times probability of B. Now tell me why you can't continue this. You're lingering. Over here you have 1/8 equals. Here, mind you, is over 1. 5 times probability of B will give you 5 what? 5 what? The probability of B. All over 12 times 1 is 12. Cross multiply. That will be 8 times 5, which is what? 40. Probability of what? B. Because 12 times 1, which is what? 12. Are you following?
Yes.
This thing you've been meeting it day in and day out. You telling me you can't do this? That will be what? 40 times the probability of B equals what? 12. You divide by what? 40. You divide by 40. This cancels that. So the probability of B will be equal to what? 12/40 is what? 3/10. Yes, so find probability of B is that simple. B occurs, okay, at the same time, can be represented in this form in probability language. That will be A intersection B. This is what it means. Okay, and once intersection comes in, that becomes a multiplication law. That will be probability of A times the probability of what? B. So what would that be? Now, the probability that event A will occur, you know that, isn't it? They said it's 1/5. Probability that event B will occur, you know that to be what? 1/3. At the end of the day, you are getting 1/15 as your answer. Any question about this? Okay. What's the next one?
Neither event.
This is 1I. Neither event occurs. probability that neither event occurs, okay, will be equal to, in probability term, that would mean probability that A does not occur. When I was introducing probability, I introduced these terms to you. The bar means what? A does not occur. Neither event occurs means A does not occur, and what? B does not also what? Occur. And that's in set language, okay? And in probability term, that will be probability that A doesn't occur multiplied by probability that B does not what? Occur. Do we understand these things?
Yes, sir.
Neither event occurs means that A does not occur, B does not occur. And we use the bar on top to indicate. Okay? But, and then when I started introducing this topic, do you remember this? But the probability that an event will not occur is equal to 1 minus the probability that the event what? Okay, so do you remember that? The probability that an event does not occur is equal to 1 minus the probability that the event what? Occurs. It occurs, okay? So over here, you would have 1 minus. The probability that A will occur from the question is 1/5. At the end of the day, what are we getting? 1 minus 1/5. Do we understand it?
4/5.
Are you sure of your answer? Also, you know that the probability that B will not occur is also given by the same formula, 1 minus the probability that B occurs. Okay? We just did this as one of the laws of probability. So that will be 1 minus. The probability that B will occur is already in the question as 1/3. What are we getting? Is it 2/3? So therefore, substituting it into your general equation, the probability that A doesn't occur and B doesn't occur will be equal to probability that A doesn't occur is 4/5 times the probability that B does not occur is 2/3. At the end of the day, you are having what? 8/15. I don't think it can be simplified further, isn't it? This should be your answer. Do you understand? If you have any question, you can ask. So you should understand the English word. Neither event occurs means that. Is that assuming that the two events are independent events? Find the probability that neither event occurs. Neither event occurs means that A does not occur and then B does not also what? Occur. Okay. Hello, are you there? I. What is there, Venice?
In a contest,
I.
I can't hear.
at least one of the events
So you see, at least one of the events occurs. At least, what do you understand by the word at least? At least means one or more. Either. In this case, we're considering two events. So at least would mean, at least probability that, read it again for me, at least what?
one of the events occurs.
One event, probability that at least one event occurs, pay attention, will be equal to I here. So at least one of the events occurs will be equal to the probability that A occurs. Okay? Or the probability that Okay, let me put it in this form for you to understand. So it can be done in two forms. You know, at least one of the events occurs. So I can solve it in two ways. This is the first way. The probability that at least one event occurs means that the the probability that A occurs, okay, or the probability that B occurs, or the probability that both A and B occurs. So that's what it means, okay. And what does that suggest to you? I said you meet this. Probability that at least one event occurs means the probability that A occurs, or the probability that B occurs, or the probability that both A and B occurs. Which of the laws is read like that? Yes, which of the laws is read like that? That's this now. The probability that A or B what? Okay, so there's a law. Okay, well, I told you it means the probability that in set form the probability of A union what? B, which can be re-expressed as well, the probability that A occurs, alright, plus the probability that B occurs, minus the probability that A and B occurs at the same time. I told you this, that this is read as the probability that A occurs, or the probability that B occurs, or the probability that both A and B occurs. I told you. That's how this is read. And I told you that going forward, you meet one English word and analyzing it, you realize that it means one of the law. And the word is at least. So at least, at least means either one event occurs, and the two events we're talking about is A and B. So it's either A and B occurs or what? Both of them occurs at the same time. Either. So if you know this, I believe you understand it. If you know this, the probability of A occurring, you know that as 1/5. Plus the probability that B occurs is 1/3. So that will be minus. Now A intersection B will be what, please? A is 1/5. Are you there? Intersection means times, or intersection means what? It's plus. Hey, are we here? You seem to be missing. Intersection means times, sorry.
Yeah, thanks.
So B will be 1/3. So let's do that and see what we are getting. For this side, what are we getting? It's 15. Over 15 minus 1/15. You are getting 7/15, right? Mm-hmm. 7/15. So that is it for at least one event occurs. I even have another way. The law. I mean, the addition law, there's how it's interpreted. So are you ready?
Yes, sir.
The addition law, there's how it's interpreted. There's another way. Applying common sense. Pay attention. The probability, you see, the probability that event A occurs is 1/5, and the probability that event B occurs is 1/3. Assuming the two events are independent events. In fact, that's the main reason why here you did not make it 0. They told you they are independent events. They are not mutually exclusive. Alright. Now find the probability that at least one of the events occurs. Are you here? At least one of the events occurs means, pay attention. The probability that at least one event what? Occurs will be equal to, what are the events involved? So it will be equal to the probability that A occurred, you understand, and B doesn't occur, all right? Or the probability that, you see, at least one happened, all right? Or the probability that A did not occur, but B what occurred, all right? At least one. Or at least one would mean, or the probability that both A and B what occurred at the same time. At least one of the events occurred. Applying logic, it means that there are two things here. At least one of the events occurred would mean that either one, A came and then B didn't show up, all right? Or B showed up but then A didn't show up, or both of them shown up. At least would mean, at least one would mean either one or more. So here you can see it's one. Here it's one, but here it's more than one. You get that? That's what at least means. Either. Get ready for this question. There's three things involved. We will analyze that together. So before that, what would we get? That would be, so now, probability that A occurs will be 1/5 if you read the question. Intersection means times, isn't it? Probability that B doesn't occur is a leading question. We've calculated that to be what, 2/3, isn't it? Plus probability that A does not occur, we've calculated that to be what, 4/5, isn't it? Times probability that B occurs is already in the question as 1/3, right? All means plus probability that A occurs is 1/5, isn't it? And then B occurs is what? 1/3. Please, are you here? You're all in the question. So here you have 2/15 plus 4/15 plus 1/15. Check this one out. You still get what? 7/15. Check it out. So there is an alternative approach. Alternatively, why am I saying so? The addition law I quoted for you is just for 2 events. What if it's 3 events and you haven't at least? You don't have a formula for that. What if it's 3 events? Here is 2 events. You are going to meet another 3 events there. What if it's 3 events? You don't have a formula. How would you go by that? So if you apply the common sense behind it, you are good to go. Are you there? Hello, are you there? So you take a look at this question. Number 2. Number 2. So in a contest, Fakpo, Osei, and Anani are asked to solve a problem. The respective probabilities that they solve the problem are 1/6, 1/8, and 1/3. Okay. Calculate the probability that A, none of them solves the problem. Do that yourself. Let's take it one after the other. It's 3 parties involved, so the writing is going to be plenty. That would mean what? What are the people we're talking about? The answer is in your mind. So if you are saying none of them solves the problem, what does it mean? That means the probability that what are those we're talking about? Come on. Dennis, how many people are we talking about on the board? 3. Yes, what are those? Mary, say one. Papo. So you know the answers and you are silent. Wisdom, yes. Anani, and then was saying. So if you say probability that none of them solves a problem, mathematically, what does it mean? Probability that would mean probability that Papo couldn't solve, isn't it? You use this to indicate couldn't solve, isn't it? And none of them could solve. So, and you're using and, isn't it? Or you're going to say or none of them. And the probability that who or say couldn't solve and Anani also could not solve. This thing you've done means a lot. But then that would mean Okay, so that is it. Now, so that would mean probability that Kpakpo could not solve, okay? And means times, isn't it? Osei could not solve times Anani could not solve. Alright? Then we start by saying, but the probability that, Kpakpo couldn't solve would be 1 minus the probability that he could solve, isn't it? And that would be 1 minus. Yes, what's the probability that Kpakpo could solve the question? Rosemont. What's the probability that you could solve the question? Are you following? Yes. It's what? 1 over 6. Are you following? So what will be the answer? Am I right? Check it out for me. 5 over 6, eh? And then 7 over 15. That's right. And then the probability that Osei could not solve is 1 minus the probability that he could solve. Yes, 1 minus Sarah. The probability that Osei could solve a question was what from the question? So are you getting 7 over 8 as a final answer? And the probability that Anani could not solve a problem is 1 minus the probability that Anani could solve a problem. And that's what? 1 minus 1 over 3. Which is 2 over 3, isn't it? Are you following the trend? Therefore, probability that Kpakpo could not solve and Osei could not solve and Anani could not solve will be equal to 5 over 6 times 7 over 8 times 2 over 3. Final answer, please. Five over 6 times 7 over 8 times 2 over 3. So I took the calculator, I'm done. Those with the calculator, they couldn't even finish. 35 over 72. So there's the answer. So simple. So simple. You understand? Hello. I believe you understand it. One of them solves a problem. I wish it would go there. Yes, will be equal to at least one of them solves a problem will be equal to how many people are involved. So now pay attention. So at least one of them solves a problem could mean all these things. The probability that Kpakpo could solve and then or say not and not, okay, or the probability that Kpakpo not but Osei could but Anani also couldn't, or the probability that Kpakpo not Osei not but Anani could, or at least it means that, or the probability that Kpakpo and Osei they could and Anani couldn't. Do you agree with me? Yes, at least one means like one or more than one. So it could be that two people could solve. So now look at the trend and help me out. Or the probability that Kpakpo could not, but Osei and Anani could. Or the probability that, since right now we've taken a look at Kpakpo and Osei being able to, isn't it? And then now Osei and Anani. So let's take a look at Kpakpo and Anani. Okay, that's the last one. Or the probability that Kpakpo, are you there? Yeah, Kpakpo could Osei couldn't, but Anani could. You get a point here. It's three things involved. So it's either Paco Osei Anani, or Paco Anani. Alright? We good. And lastly, or the probability that all the three, Paco, Osei, Anani, they could solve the problem. At least one. This is what it means. Okay, that's when the terms are what? Three. If you miss one, brethren, your answer will be way different from what we have in the marking scheme. Now, I believe you know all that. You felt the stimuli that I'm come to attack you. So they use it back on again. Oh, you feeling cold?
No.
No. Wow. You're not feeling cold, eh? Let's help a sister. Alright, so that is it. Make sure you understand this right up. Now, what's the probability that Paco could solve a problem, please? That's 1/6. 1/6. Intersection means times. The probability that Osei could not solve a problem is already on the board. That's 7/8. Anani could not solve a problem. That's 2/3. All means plus. The probability that Paco could not solve a problem is 5/6. Times Osei could solve a problem. That's 1/8. Probability that Anani could not solve a problem is 2/3. Plus the probability that Paco could not solve a problem is 5/6. Times Osei could not solve a problem is 7/8. Times Anani could solve a problem is
Sir.
Yes.
Please, Osei and Anani, they couldn't solve the problem. We have two options over there.
1/3. Right, and then the probability that Paco could solve a problem is 1/6. Times the probability that Osei could solve a problem from the question is 1/8. Times the probability that Anani could not solve a problem has been calculated as 2/3. Alright. So plus now coming here, the probability that Paco could not solve a problem is calculated as 5/6. Times the probability that Osei could solve a problem is given in the question as 1/8. Times the probability that Anani could solve a problem is also 1/3. Then plus the probability that Paco could solve a problem is 1/6 times the probability that Osei could not solve a problem is calculated as 7/8 times the probability that Anani could solve a problem is 1/3. Then lastly plus the probability that all of them could solve a problem is given as 1/6. So you multiply that to 1/8 times 1/3. So if you multiply this, you have 7/72. You have it to, if you multiply this, you have 5/72. This one to 35/144. This bracket will give you 1/72. This bracket will give you 5/144. Plus this bracket will give you 7/144. This bracket will give you 1/144. At the end of the day, if you add all these, you have 37/72. So that ends it. You and your phone. Dennis, put the phone down. What are you doing? What's happened?
This time, about 12.
Which people will be awake at this time? Tell me. There are plenty. The youth these days, they are witches and wizards. Midnight bundle. I'm on Nankem. Are you taking a... Okay. What did she say? I'm so curious. What did she say? Or is girl stuff?
It's a girl stuff.
You.
I had a man girl stuff.
Girls.
Oh, Linda too said she would pass through.
Hey,
And what happened? She said she's scared.
They will pay, don't come.
She was saying she was scared of something like that. Well done.
What?
I think, I don't know if the time we close or something like that.
I saw Miss Martin. I'm a pastor.
You can
How get done?
You pause that. Yeah, so that is it. That is going to be forward 20. Okay, it's correct. Yeah, it's correct. Well done. Number 2. At least one was present. Now you're familiar with at least, yes? At least one was present. At least, what are you getting? I'll not call you to the board, just tell me your answer. Alright. Yes. Yes. Wisdom, what are you getting? Mary, warm up and come and do the part I for us. At least, yes. At least. At least one was present. That will be the probability that K or B or both were present. You quoted the formula wrongly. I see you trying to use the addition law. It's fine. But you quoted it wrongly. Per the addition law, that's going to be, is that how to put the addition law? That will be equal to probability of K plus probability of B minus probability of K intersection B. So here you have to continue. The second line, probability of K plus probability of B is minus probability of K intersection B. That's the addition law. But because it's two things involved, yes.
So is it negative?
Come again.
Negative.
No.
Yeah.
At least one of the events occurring means probability. So that's what it means. Probability that K occurred or B occurred or both K and B occurred at the same time. That's the addition law. And you haven't. So you have to now K occurring. The question is 1/5. Okay, minus. So you were doing the right thing, but you quoted the law wrongly. But 19/20 is for what? Okay. So clean, take the duster and clean that middle step. P, yeah, that thing, I don't know what you're doing.
Is this side correct?
Yeah, everything is correct. You know, it was K union B, and there's the addition law. Go and refer. What is K union B? Alright, so it's correct. But I wish you understand the second approach. So alternatively, what's the other way to solve this question and get 4/5? Yes, what's the other way? Yes, what's the other way? Are you recording?
Yes, sir.
Are you sure you recorded this? Yes, the second, what's the other way to solve this and I get the same answer? Yes, what's the other way? Dennis, are you here? What's the other way? What is the other way? Probability that at least one was present is here. So this when you see one was present means probability that Kofi was present or the brother was present or both were present. That's the interpretation. And you know, I told you that particular statement, probability that the Kofi was present or the brother was present or both was present, mimics the addition law. So we can use the addition law. Or another way is that at least one of them was present means put on the ACN. It means the probability that Kofi was present and the brother wasn't present. Or I wish you know of this, because when you made the thread set, you struggle when you're trying to use this law. Because the law is just for two parties. Or the probability that Kofi wasn't present and the brother was present, or the probability that both of them were what? Present. Please, are you here? And you know, the probability that Kofi was present, what's the answer?
What? 1 over 5.
1 over 5, are you sure? The brother wasn't present. Have you done that calculations yet? That would be 1 minus 3 over 5. What is that? 1 minus 3 over 4.
3 over 4. It's 1 over 4.
1 over 4, right? 1 minus 3 over 4. You sure?
Yes, it's 1 over 4.
Plus 1 minus 1 over 5 is what?
It's 6 over 5.
You sure?
Yes.
1 minus 1 over 5.
6 over 5.
Are you sure?
Yes.
Check from your calculator.
So 1 over
1 minus
4 over 5.
1 minus 1 over 5.
yeah.
Okay, plus here will be 1 over 5 times 3 over 5. Over 4, sorry. We are having 1 over 20 plus 20 plus 3 over 20. Check and see what you'll be getting. I think it's 15 over 20, yes. And can it be reduced further?
Yes.
What are you
3
getting?
over 4.
Come again.
3 over 4.
You sure?
Yes.
Then there's something wrong. Are you having 3 over 4?
No.
1 over 20 plus 4 over 20 plus 3 over 20 is giving what?
Yes.
16.
It's what? 16 over 20. Yes. And the final answer is what? 4 over 5. There's an alternative approach. And I'm much concerned about how, you getting familiarized with this because of questions that involve 3 problems. Okay. This okay. This okay, but when you meet 3, just get ready for questions like this in exam. What are you going to do? So yeah, that's it. This union, Mary. Union, it's not you. Yes. Mrs. Jones is expecting a baby. The probability that the baby will be a boy is 1 over 2. And the probability that the baby will have blue eyes is 1 over 4. What is the probability that she will have a blue-eyed baby? Was that a question? If so, then you're good to go. Where is that?
So the question 3,
Yes. So what are you getting? This is English. Yes. Okay, what is that? Exactly one of them.
It's present.
One of them is present, yes. So, yes, what is that? It's simple. Oh, you have one? Yeah, that is it. It's simple. Probability that exactly. We've been doing this all over and over again. So it's got to the probability that exactly one of them. So it's either Kofi is present and the brother isn't, or the probability that Kofi is not present and the brother is. That's all. Exactly one of them. You know, Kofi being present to be 1/5 times the brother being present, not being present is what? 1/4 plus Kofi not being present is 4/5 and the brother being present is what? 3/4. So you have 1/20 plus 12/20. You said you had what? 13/1.
20.
Yeah, that's it. Okay, you have another question. So, yes, Mrs. Jones is suspecting a baby. The probability that the baby will be a boy is half. And the probability that the baby will have blue eyes is 1/4. What's the probability that she will have a blue eye baby?
From the ball.
Do you understand what she's saying?
Yeah.
Probability that the baby being a boy and then having blue eyes.
Yeah.
Case closed.
Yeah.
But in exam, in exam, who understand B? Basic education.
So, if we add a D to become D.
Okay. Go to the school platform. Sir, give me the phone.
Rosemont.
I'm 4 classes.
Rosemont, I'm waiting for you.
Class 4.
A bag contains 10 balls that differ only in color. 4 are red and 6 are blue. Sorry, 4 are blue and 6 are red. Now, so a bag contains 10 balls, alright? 4 of which are blue, 6 are red. Now, 2 balls are picked one after the other with replacement. Pay attention. 2 balls are picked. Pay attention. It's very important. 2 balls are picked from the bag one after the other with replacement. Do you know what that means? When you pick the first ball, you replace, you put that down. Either then you pick the second ball, and it has a lot of influence on what you are come to do here. So what's the probability that both are red? So probability that both are red, because the probability that now, how many balls are you picking? 2, isn't it? So the first draw you did, okay, the probability that, listen, the probability that the first draw, the first picking, okay, was red, and the second pick was also red, because they are saying both are red. That's the interpretation. You are picking 2 balls with replacement. Find the probability that both are red. That would mean the first thing you picked was red, the second was also red. Now pay attention again. Now if you're picking a red ball on the first draw, that's going to be 4. Okay, how many? 6, isn't it? 6 out of, what's the total number of balls? 10. And means what? Times. Now, if you pick in a red ball again on the second instance, that will be 6 on what? 10. What if I use the word without replacement? Without replacement. You picking two balls were picked at random, either one after the other without replacement. Do you know what it's going to mean? 2 balls were picked, so that would mean, and you have been asked to find a probability that both are red. This is going to be this way. Probability that both are red will mean the first thing you picked was what? Red, and then the second pick was red. But let's look at the values. The first pick being red will be what? 6 over 10. Without replacement. So after picking the ball, you did not replace it back in the bag. That would mean that the second picking, okay, the number of balls will not be 6. To reduce by 1. So it will be 5. And the total number of balls will also reduce. 8 bar.
9.
The total number of balls is 10. But mind you, you've already taken 1.
1 already.
And so you'll be left with 9.
Wisdom.
Either. So you pick the first one. And then so you'll be 6 over 10. But the second draw, if it's about red balls, mind you that the first ball you took was what? 6. So now it will reduce by 1. So it's 5. And the number of the total number of balls has also been reduced by 1. So that will be what? 5 over 9. Either. That's how the multiplication will be when you've been told without replacement. That was just by the way. That will be 36 over what? 100. What's the answer? Is that it? Okay. 9. Okay, give me the decimal. 9 over 25.
Yes.
Alright. Or 0.36. Alright. So both are of the same. How do I interpret this? Like you are picking 2 balls, one after the other with replacement. Okay. Find a probability that both are of the same color. This is simple now. Both are of the same color. That would be the probability that like the first one you picked was red, okay, and the second was red, or the probability that the first of the same color. So and it's 2 colors involved, red and blue. So it's either the first you picked was red and the second was red, or the first you picked was what? Green. Also blue, and the second was what? Blue. Are you paying attention?
Yes, sir.
So if the first was red, that would be what? 6 over 10 times 6 over 10. All means plus. If it's blue, it's going to be what? 4 over 10 times 4 over 10. 36 over 100 plus 16 over 100. 52 over 100 or 0.52. You are sleeping and I'll pour the water on you if you don't get up. 0.52. Yes. Any question?
15 over 100 can be reduced to 13 over 25.
Yeah. But I think the decimal is okay. At the end of the day, get 0.5%. Both are of the same color. I believe you understand it. See.
Sir. I understand this, Papa. See, when you were.
Say, see.
Without replacement.
Yes, that's right. No, with a replacement. Not P about 1 hour intersection 2 hours. When you came, there was about 10 times about 10. Why didn't you write
5 over 9.
no without
2 times 6 over 10.
Eh.
Oh, come on. Yeah, well, it's okay, but I mean, me teaching here, Picking red on the first draw will be 6 over. It's better to do it this way. That would make you understand. Where from the 2? Or is it because you are having 6 over 10, 6 over 10? Well, if you choose to multiply by 2, it's fine. But hey, this time for this, this time for that.
I just am saying that the second one, why didn't you write 2 into bracket 6 over 10? Then you multiply it with the other 6 over 10.
The same thing. Like, you mean from here? Why are you making your step too long? You mean I should have done this?
Times this 6 over 10. See that in the
She's saying that because of the 1R
and
It doesn't mean 1 times. No. What this means is that I said, listen to what I see. 2 balls are picked one after the other with replacement. You pick, you put it back. Huh? So the probability that both are red means like the first draw was red. First draw was red, and then the second draw was red. Both are red. That's what it means. First draw being red and second draw being red. I'm tired. Are you there? It's 2. Any question? But I've spoken to you about without replacement. I'll go and fetch for a question and see how you handle it.